units of volume over area over time, which equates to length over time, so that's our velocity. So there you go, this is our unit area, okay, and water flowing through it, and a gradient of 1, okay, and the rate of water flowing through there is our hydraulic conductivity. It's a very useful property. Here's some issues, which we'll talk about later, but it's still very useful. It's one of those things that you really need to quantify about an aquifer. It's going to tell you whether the aquifer will be able to provide you the amount of water you need from it, or whether it will not be able to, and will just sort of die. Very important when you're designing water wells. But you have to calculate the rate of groundwater movement. It's a measure of how easily fluid passes through a particular media. It's also a measure of the fluid properties and the properties of the media. It's a mixed measurement. Okay? So if you change any one of the properties, the density of the fluid, or the temperature of the fluid, or whatever, or the porosity of the material it's flowing through, or whatever, K will change. Okay? It's dependent on both the matrix and the fluid properties. It's not a measure of permeability of how easily material will flow through. Okay, it just calculates, just showing you the rate at which it does. Okay, and it's specific to particular combinations of fluid and media, as any of these values would be. Large K is good if you're looking to get water out of the ground. Okay, large K is good. It will flow through the media really well, and you should be able to extract it with decent amounts that will recharge the well, as long as there's still water to do that. And you can calculate K using Darcy's law, because it was part of Darcy's law before, so by rearranging equations, you can calculate what K is. So Q equals K times the area times hydraulic gradient. Of course, you can rearrange things. K becomes discharge over the area times the hydraulic gradient. So you can't calculate that. But of course, you don't know some of these things until you start digging and playing in the ground. Okay? So you need other ways to determine what these properties are as well. You can estimate it from lab testing, but you can grab material and do an experiment similar to what Darcy did to work out what K is. Displacement testing, we talk about this, we talk about the initial stages of groundwater development. Okay, we do various things to piezometers and measure the amount, the rate at which water drops or fills back up in a hole, and you can work out what K is. And of course, the best way is through actual flow testing, pump testing as well, packet tests. All these things we'll be dealing with in future lecture. Okay, these things you actually do out in the wild, in holes, with water and measuring equipment. We actually get values out, chuck it in software, and get things like K, S, and T, which we'll be dealing with in a minute as well. Yeah. Carry on Wednesday. Just remember all that stuff for Wednesday.
Good luck.